Hi everyone, today we'll be looking at the November 2018 paper 2 of the GCSE mathematics. Question 1, we're being told that the universal set consists of all even numbers between 1 and 25, and we've got three sets A, B, and C, and we need to complete the Venn diagram with this information. I will start by identifying the common elements between A, B, and C, and this is just the number 8. So 8 goes in the middle here, and then 20 is common to both B and C. So 20 should go here. There are no other elements in common, which means that we've got 2, 10, and 14 here in the only A region. We've got 6 in the only B region, and we've got 18 and 22 in the only C region. In addition, bearing in mind that the universal set has other elements as well, notice that we also need to add 4, 12, 16, and 24 outside of the three sets in order to have a complete picture of all the even numbers between 1 and 25. A number is chosen at random from the universal set. What is the probability that this number is a member of A intersection B? Well, A intersection B is this part here. So there's only one element, and it's going to be 1 out of 12, 12 being the total number of elements in the universal set. Question 2, Sean has information about the height and the weight of 10 rugby players. He drew this scatter graph and the line of best fit, and we need to write down two things that are wrong with this answer. So I will start by looking at the horizontal axis. We notice that we go from 140 to 160 and then to 170. So obviously the scaling on the horizontal axis is wrong. So horizontal axis scaling is wrong, and 150 is missing. And then if we look at the line of best fit that was drawn here, it's obviously wrong. I expected something like this, so the line of best fit is incorrect. Question 3, we're being given a triangle BEG. We have A, B, C, and D, E, F being parallel lines, and we need to work out the size of angle X. X is right here, it's BGE. I could start by finding the angle BEG because I know the 110 and the 25. I need to be giving reasons here. So BEG is 180 minus 110 plus 25, which is equal to 45 degrees, and the reason is angles on a line add up to 180 degrees. Now it's a good idea to keep updating the diagram with all the information as it comes to light. So 45 degrees goes here, and then I'm gonna use the fact that the two lines are parallel to find this angle here. Now the angle ABE with the 110 are interior angles, so they add up to 180. So ABE is 180 minus 110, which is 70, and the reason is interior angles add up to 180 degrees. So the 70 will go here, and so this missing angle is again angles on a straight line. So EBG is 180 minus 70 plus 35, which is 75 degrees. Angles on a line add up to 180 degrees. So the 75 degrees will go here, And now that I've got the two angles here, x is just the angle needed to make the sum 180. So that's gonna be x is 180 minus 75 plus 45, which is 60. And the reason is angles in a triangle add up to 180 degrees. Number 4, Northern Bank has two types of account. Both accounts pay compound interest, and we've got Ali who's investing 2,000 in the first account, and then Ben who's investing 1,600 in the second account, in the shares account. We need to work out who will get the most interest by the end of the 3 years. So for Ali, we've got 2,000 originally invested. Now, each year the amount of money increases by 2.5%. So this is a multiplier of 1.025. And this will happen for 3 consecutive years. So I raise to the power of 3, giving an answer of 2153.78. And therefore the interest gained is simply the total amount of the investment at the end of the 3 years minus the original amount invested, which is £153.78. I'm gonna do the same for Ben. So Ben invested 1,600. He's attracting an interest of 3.5%, so the multiplier is 1.035, again raised to the power of 3, which is giving 1773.95. This means that the interest is gonna be 173.95. So since 173.95 is greater than 153.78, Ben will get the most interest. In the 3rd year, the rate of interest for the shares account is changed to 4% per annum. Does this affect who will get the most interest by the end of 3 years? Give a reason for your answer. Now, the shares account was originally at 3.5% per annum. Now it's gonna increase. So this means that Ben will actually get even more. So Ben was already ahead, so they will stay ahead. So the answer here is no, since this will increase the interest Ben earns. Who already gets more than Ali. Question 5, we've got the diagram showing a floor in the shape of a trapezium. Base 1 is 10, base 2 is 16, the height is 7. Now we're gonna paint the floor. We've got each 5-liter tin of paint costing $16.99 with a liter covering an area of 2 square meters. Now John has 160 pounds to spend on paint, and the question is whether we've got enough money to buy all the paint we need. So I will start by calculating the area of the trapezium. So this will be 10 plus 16 over 2 times 7. It's a base times height, sorry, base 1 plus base 2 over 2 times the height, which is 91 square meters. Now we know that a liter of paint is enough to cover 2 square meters. So how many liters to cover the 91 square meters? So X is 1 times 91 over 2, which is 45.5 liters. Now we were told that the paint is coming in tins of 5 liters, so 45.5 over 5 is 9.1, so we need 10 tins. and each costing 16.99, means that we need a total of 169.90 pounds, which is greater than 160, and therefore there is not enough money. In question 6, A is the point with coordinates 5, 9, B is the point with coordinates D, 15. We know that the gradient is 3 and we need to work out the value of D. So let's start by reminding ourselves that the gradient is given by y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are the 2 points through which the line passes. So m is 3 is equal to 15 minus 9 over d minus 5. I will cross multiply, so 3 brackets d minus 5 is equal to 6. So d minus 5 is equal to 2, which means that d is 7. Question 7, write the number 0.0008623 in standard form. Remember that in standard form we need to make the number between 1 and 10, so the decimal point needs to move 1, 2, 3, 4, 5 places to the right. So it's going to be 8.623 times 10 to the negative 5. And in B, we need to work out the value of this, giving an answer in standard form correct to 3SF. Well, I'm just going to plug this everything on the calculator. I get an answer of 7441979.07, which in standard form to 3SF will be 7.44 times 10 to the 6, because the decimal point has been moved by 6 places to make the number here between 1 and 10. 8. Triangle P is reflected in the line y equals to negative x to give triangle Q. So this is the line y equals to negative x. We're going to reflect the triangle P to obtain triangle Q. So a nice approach will be to take each of the coordinates of the vertices. So this one is minus 1, 3, and reflecting along the line y equals to x means interchange the x and the y's and change their signs. So minus 1, 3 will go to minus 3, 1. So it's gonna be here. I'm gonna do a similar thing with this vertex here, which is at 3, 3. It will go at the minus 3, minus 3. And finally for the third vertex, and this will give triangle Q here. So I'm gonna label it and then proceed with Q, which is now reflected along the line x equals to negative 1. So this is the line of reflection. X is negative 1. So the distance I am to the left of the mirror line is going to be the distance the image will be found on the right of the mirror line. So it's going to be here. So this is R here, and we need to describe fully how I can go from R to P. I see that the orientation has changed, so it's obviously a rotation. I can use my tracing paper to identify the center of the rotation and the angle and direction of the rotation. So it turns out that it's a rotation through 90 degrees anti-clockwise, about minus 1, 1. 9, Martin truncates the number n to 1 digit. The result is 7. So we need to write down the error interval for capital N. So if we truncated, it's not rounding, we truncated the result to 7. So it could be 7 point anything from 0, 0, 0 up to 7.9999. So it's gonna be 7 less than or equal to n less than 8. It's a strict inequality with the 8. 10, Robert makes 50 liters of green paint by mixing yellow and blue paint in the ratio 2:3. Now yellow paint is sold in 5-liter tins, each costing £26, whereas blue paint is sold in 10-liter tins, each costing £48. This will lead to 10-liter tins of green paint, which we will be selling for $66.96, and we need to work out the percentage profit. I like to approach this question through a table. We've got the yellow paint, we've got blue paint, and it's the total here. It's the green paint actually, the total. So we've got this in the ratio 2:3, and this means the total is 5. So in terms of liters, it's obvious that because he's making 50 liters of green paint, then it's gonna be 20 liters of yellow paint and 30 liters of blue paint. Now, in terms of the number of tins, the yellow paint is sold in tins of 5 liters, so we want 4 tins of yellow paint, and the blue paint is sold in 10-liter tins, so we need 3 blue tins. What is the cost now? Each tin of yellow paint is costing £26, so 4 times 26 is 104, and 3 times 48 is 144. Now, in terms of the total being the green paint, we have 50 liters, and it will be sold in 10-liter tins, so we will be having 5 tins, each one sold for $66.96. So 5 times 66.96 is 334.80. So the total cost is just the sum of 104 and 144, which is 248. And to find the percentage profit, I will be dividing the income, the 334.80, by the cost of 248, which gives me an answer of 1.35, and therefore we're looking at a 35% profit. 11. In a restaurant, there are 9 starter dishes, there are 15 main dishes and 8 dessert dishes, and Janet's gonna choose one of the following combinations. It could be a starter and a main and a dessert, or a starter, main, and a dessert. And we need to show that there are 1,335 different ways to choose the meal. So I will start by considering the starter and main combination. So we've got 9 options for a starter and 15 for a main. So 9 times 15 is 135. For the main and dessert, it's gonna be 15 times 8, which is 120. And for the starter, main, and dessert, it's gonna be 9 times 15 times 8, which is 1,080. So if I add up these 3 numbers, 1,080 plus 120 plus 135, it's 1,335 as required. 12, we need to write 4x squared minus 9 over 6x plus 9 times 2x over x squared minus 3x in this form. I will start by simplifying and factorizing. So 4x squared minus 9 is the difference of 2 squares. It's 2x minus 3, 2x plus 3. 6x plus 9 has a common factor of 3, leaving 2x plus 3 in the bracket. And x squared minus 3x is giving me x brackets x minus 3, and I also have the 2x here. Now, the 2x plus 3 with the 2x plus 3, they cancel out. The x with the x cancels out. So if I expand the numerator, it's going to be 4x minus 6, and in the denominator is 3x minus 9. And this matches the form I had to give my answer to. B, we need to express this as a single fraction. Well, I'll have to start by considering the LCM, which is just the product of the three denominators, x plus 1, x minus 2. The first fraction needs to be multiplied by x minus 2 in order to make the denominator be the same as the LCM. The second fraction needs an x plus 1, and the final one, it needs an x plus 1 times x minus 2. So I'm expressing everything over the same denominator here, x plus 1, x minus 2. So it's going to be 3x minus 2 plus x plus 1 minus 4 brackets x plus 1, x minus 2. A common mistake is for people to try to do too many things in one go. Now we have expressed everything over the same denominator. Now we will proceed with expanding. It's 3x squared minus 6x plus x squared plus x minus 4 bracket x squared minus 2x plus x minus 2 all over the x plus 1, x minus 2, leading to 4x squared minus 5x minus 4x squared plus 8x minus 4x plus 8. Do not forget the denominator. Another common mistake is for people to ignore the denominator, they throw it away. 4x squared minus 4x squared, they cancel out. Minus 5x plus 8x is 3x, minus 4x is negative x, plus 8 over x plus 1, x minus 2. 13, it's a diagram showing a circle and an equilateral triangle. One side of the triangle is a diameter. It has a circumference of 44 centimeters, the circle. We need to work out the area of the triangle. So this is the radius here. This is r, so this is also r. Because this is an equilateral triangle, this means that all sides are equal in length. So this will also be 2r. We know that the circumference of the circle is given by 2 pi r. 2 pi r is 44. So r is 44 over 2 pi. We also know that the angle here should be 60 degrees, this being an equilateral triangle, and the area is a half AB sine C, so a half times 2r times 2r times sine of 60, and in the place of r I will be putting 44 over 2 pi, so it's a half, 2 times 44 over 2 pi times 2 times 44 over 2 pi times sine of 60. I'll plug everything on the calculator as it stands and I get an answer of 84.9 squared centimeters. 14, we need to sketch the curve with the equation of y is 2 to the x. Well, when x is 0, we get that y is 2 to the 0, which is 1. And we also know that when x becomes progressively larger, then y tends to infinity, so it's going to be up here. Whereas when x is very large and negative, then 2 to the x would be something really close to 0. So this would be something like this, cutting at 1. Actually, the x-axis is an asymptote. 15, the equation of a circle is x squared plus y squared is 42.25. Find the radius of the circle. Now, the equation of a circle is x squared plus y squared is r squared if the center is at the origin. So by comparing, the 42.25 is r squared. So r squared is 42.25, which means that r is the square root of this, which gives an answer of 6.5. 16, there are only red counters and blue counters in the bag. The probability we pick a red counter is 0.65. We pick one at random, we check, we put it back, then Mary takes another one at random. What is the probability that both take counters of different colors? I could illustrate this on a probability tree diagram. Red, blue. If the probability of getting a red is 0.65, it means that the probability of getting a blue one is 0.35, because these two numbers need to add up to 1. And then I'm gonna draw once more with the same situation, so it's 0.65, 0.35. Because the first counter has been returned, it means that we are looking at exactly the same probabilities, and we're now interested in the probability of taking counters of different colors. So it's gonna be either red, blue, or blue, red. So I multiply the probability of the branches through which I travel. It's gonna be either red, blue, or blue, red. The or translates into a plus, and this gives an answer of 0.455. There are 78 red counters in the bag. How many blue counters are there? Well, if a proportion of 0.65 corresponds to 78 red counters, what does a proportion of 0.35 correspond to? That will be the number of blue counters. So x is 78 times 0.35 over 0.65, and this gives an answer of 42 blue counters. In 17, we've got P and Q, two numbers with P being greater than Q. If we subtract 5 from P and 5 from Q, then the answers are in the ratio 5 to 1. And if we subtract 20, if we add 20 to P and we add 20 to Q, the answers are now in the ratio 5 to 2. So we're looking at simultaneous equations in P and Q. We have to be careful that we need to find the ratio P to Q in its simplest form. I will start by cross multiplying the first. P minus 5 is 5 brackets Q minus 5. So P minus 5 is 5Q minus 25, leading to P is 5Q minus 20. And then here I'm going to cross multiply 2 brackets. P plus 20 is 5 brackets Q plus 20, leading to 2P plus 40 is 5Q plus 100. So 2P is 5Q plus 60. It makes sense to multiply everything here by 2. So 2P is 10Q minus 40, which means I can now equate 10Q minus 40 with 5Q plus 60. So 10Q minus 40 is 5Q plus 60, leading to 5Q being 100. So Q is 20. And P is 5 times 20 minus 20, which is 80. So P to Q is 80 to 20, which simplifies to 4 to 1. 18, the straight line L1 passes through the points 4, 6, 12, 2. The straight line L2 passes through the origin and has a gradient of negative 3. We need to find the coordinates of the point of intersection of the two lines. So I will start with L1. The gradient is y2 minus y1 over x2 minus x1, and this is equal to minus a half. So it's the equation is y is minus a half x plus c. Now when x is 4, y is 6, which means that 6 is minus a half times 4 plus c. 6 is negative 2 plus c, so we got a to be c. So y is minus a half x plus 8 is the equation of L1. L2, it passes through the origin, it has a gradient of -3, so y equals to -3x is the equation of L2. And now I will equate the two. -3x is -1/2x plus 8. I will multiply everything by 2 to get rid of the fractions. And I get -5x is 16. So x is -16/5. That's the x coordinate. Y is -3x, which leads to 48/5. So this is -16/5, 48/5. 19, we need to solve this quadratic inequality. So I will start by splitting into 1 and then 2. So 22 less than m squared plus 7/4, leading to 88 less than m squared plus 7. So 0 less than m squared minus 81. This factorizes, it's the difference of two squares, so m minus 9, m plus 9, giving me critical values of 9 and -9. It's a quadratic inequality. We always sketch the parabola here, cutting at -9 and 9. It goes from plus to minus and then again plus, and we want to be greater than 0. So we want the plus region. So we want to be having m less than -9 or m greater than 9. Now, for this part, I have m squared plus 7/4 less than 32. So m squared plus 7 is less than 128, leading to m squared minus 121 less than 0. Again, the difference of two squares, so m minus 11, m plus 11. So the critical values are 11 and -11. Again, I draw my parabola. It's a smiley face parabola, cutting at -11 and 11, plus, minus, plus. We want to be less than 0, so we want to be between -11 and 11. And the solution to the original problem is essentially when both of these are being satisfied. So it's really useful if we could illustrate all of these on a number line here. For m, we've got -11, -9, 9, 11. We want to be greater than 9 or less than -9. And we want to be between -11 and 11. So here, here. And sorry, it's gonna be here. So we need to extend this to be up to 11 over here. So when are both of them satisfied? It's the intersection of the two, between -11 and -9, and between 9 and 11. So -11 less than m less than -9. Union, which means or 9 less than m less than 11. Be careful, we should be using m, not x, because the question was phrased in terms of m. 20, we've got a frustum of a cone, and the frustum is essentially made by removing a cone from a larger cone, and it is then joined to a solid hemisphere to give this solid S, and we need to work out the average density of solid S. I will start by looking at this cone here. The height is 6.4, the radius here is 3.2, 3.6, sorry. Because I'm cutting it halfway through, it means that the radius gets halved as well, so it's 1.8. So I would like to draw a table here to illustrate all of this. So it's the hemisphere and the frustum, And the volume of the hemisphere, well, we are given the formula for the volume of a sphere, which is 4 over 3 pi r cubed. We've got a hemisphere, it's going to be half of that. So it's going to be a half of 4 pi, and the radius is 3.6, so 3.6 cubed. And this gives an answer of 97.7161 cubic centimeters. The density of the hemisphere is 4.8 grams per cubic centimeter. And looking at the frustum, where the volume of the frustum is going to be the volume of the big cone, take away the volume of the smaller cone. So the volume of the cone is a third pi r squared h. So it's going to be a third pi, the radius is 3.6 squared, the height is 6.4, minus a third pi 1.8 squared times 3.2, which is the volume of the smaller cone, and this is 76.0014 cubic centimeters, and the density of the frustum is 2.4 grams per cubic centimeter. Now, to find the mass, where we know that density is mass over volume, so to find the mass, we're just going to be multiplying density with volume, and I'm going to do 97.7161 times 4.8, which gives an answer of 169.037 grams. And for the frustum, it's going to be 76.0014 times 2.4, which gives an answer of 182.403 grams. Now, the total volume is just the sum of these two numbers, which gives an answer of 173.718 cubic centimeters, and the grams, the mass is 651.441 grams, which means that the density is just this mass of 651.441 over the total volume of 173.718, which gives an answer of 3.75 grams per cubic centimeters. If you maintain full accuracy throughout this question, you get exactly 3.75 grams per cubic centimeter. Question 21. We've got the A, B, R, and P, 4 points on a circle centered at O, and then A, O, R, C are 4 points on a different circles. The two circles intersect at A and R, and we need to prove that angle CAB, I'm going to call this theta, and ABC, I'm going to call this phi. We need to prove that these two angles are equal. So I will start by drawing a line connecting O and R, and because OR and OB are both radii, this means that ORB is also phi. It's a prove that question, so even though no reasons are asked for explicitly, we still need to provide them. So ORB is equal to phi, angles at the base of an isosceles triangle are equal. Now, we know that AORC is a cyclic quadrilateral, and the opposite angles of a cyclic quadrilateral add up to 180 degrees. So this here should be 180 minus theta. So CRO is equal to 180 minus theta, and the reason is opposite angles of a cyclic quadrilateral add up to 180 degrees. And then it's obvious that this is a straight line, so 180 minus theta plus phi should be 180. So 180 minus theta plus phi is 180. Reason is angles on a straight line add up to 180 degrees. So the 180 with the 180, they cancel out, and I see that phi is theta. In other words, CAB and ABC are equal as required. We had to construct a proof, that's why I'm giving reasons, explaining everything. It's a good idea to keep updating the diagram as well, to have a clear picture of what you have found, and this will enlighten the next step and how to proceed in order to get to the final answer.